Assalamualaikum and hi. In this video, we are going to summarize on each experiment we have done. So there are 4 experiments, which are the first one Coulomb's law and follows by capacitance, DC circuit, and lastly magnetism. Hi, my name is Nur Shafka binti Muhammad Shabri. I will present about first experiment which Coulomb's law. First of all, the objectives in doing this experiment are to satisfy Coulomb's law experimentally, to study the parameters that affect electric force, and the last one, to find experimentally electric constant, which is K. To do this experiment, firstly we're gonna click the link that has given in the lab manual, and we can see an image will be displayed as shown in this slide. There are 2 parts in this experiment. For part 1, we're gonna fix the charge first. There are 2 charges, and we have to change the distance between 2 charges from 3 until 10 to find the rate of distance and electric force. And then the data that we have obtained, we have to record in the table as given. Meanwhile, for part 2, we have to control charge 1 and distance between 2 charges as 5 microcoulomb and 6 cm. Then charge 2 will be changed as 3 until 10 to find electric force. Data 1, we can see based on the graph where electric force versus distance, here we know that the higher the distance, the lower the electric force. While this graph shows electric force versus rate of distance, we can see that the higher the rate of distance, the higher the electric force. Proceed to the part 2 where electric force versus charge. This graph shows that if the charges are increased, then the electric force will also be increased. Here we discuss about some errors that may occur if this is face-to-face experiment and some precautions that may occur in the experiment is firstly misreading data on the measurement as the objects on the charges do not parallel to the reading scale, and secondly high voltage at the terminals of the supply can also cause leakage current. Some precautions have also been discussed in this experiment, which are firstly make sure the reading scale is parallel to the measurement to obtain the best result, and secondly we have to stand the comfortable distance away in taking the measurement in order to minimize the effect of static charges. Based on the experiment we have done, we can conclude that Coulomb's law is inversely proportional with the distance of an object. Meanwhile, it is directly proportional with the total charge of the substance. Next, we can also conclude that the distance between 2 charges and the total charge as well are the parameters that affect on electric force. That's all from me on summarizing the first experiment, which is Coulomb's law. And thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Alif Mohamed, and now I will present about experimental capacitance. There are 3 objectives. First, to study the capacitance varies with the separation between the plate. Second, to study the capacitance varies with the area of the plate. And third is to study the dielectric effect on the stored charge, energy, and voltage between the plates of the capacitor, whether it's connected with battery or not. Procedure part 1. First, select paper from the taskbar on the right, and then set up the apparatus and the material as the picture shown, and then record the value of the plate's area A, distance between the plates D, and also the corresponding capacitance. And then slowly increase the plate's area and then measure the corresponding capacitance for 4 more times. Lastly, restore back as initial and then slowly decrease the plate's area and measure the capacitance for 4 more times alongside with the reciprocal of the separation. Procedure part 2. First, remove the dielectric entirely from the capacitor. Second, connect the battery and turn on about 1 volt and measure the values effectively. And third, slowly insert the dielectric inside the capacitor and measure all the change in capacitance, charge, voltage between the plates, and energy restored. So 4, disconnect the battery and remove the dielectric entirely and repeat the step 3 and record the change. This is the result for part 1. This is the result for experiment 2 part 2. Question part. As we know, every experiment must be an error. So for this experiment, the reading slightly different because energy tend to disperse to surrounding. And for the precaution steps, so as we know, make sure our eyes must be perpendicular to the voltmeter scale, and also the setup of the apparatus must be properly connected. If not, the reading slightly change. We can conclude that based on this graph, when the area between the plate is increased, the capacitance is decreased. Based on this graph, when the separation between the plate is decreased, the capacitance is increased. We can conclude that when the battery is connected, the value of charge increase and the meter decrease. And also the voltage between the plate is constant. But when the battery is disconnected, the voltage between the plate is increased and the meter also increase, alongside with the value of charge is constant. So this is the formula for the capacitance. So capacitance equal to charge over velocity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Ali Faizal Abdul Rashid, and I will present to all of you about experiment 3, which is electricity and magnetism. Three things that we need to search for this experiment. First, to measure the current and voltage for simple DC circuit. Second, to study series connection of resistor. And third, to study parallel connection of resistor. For this experiment, there are 3 parts. Part 1, Part 2, Part 3. During Part 1, we will construct a circuit, the basic circuit, which is consists of one resistor and one battery. For the second part, we will construct a circuit, which is 2 resistor, 1 battery, and 1 breaker. And we will measure the voltage and also the current of the part of the circuit. 2 of these is the series circuit. And the third part, we will construct a parallel circuit, which consists of 2 resistors, 1 battery. We will talk about the result that we got during this experiment. We will talk about result part 2 and part 3, because part 1 is the basic circuit of the series connection. So we doesn't really know the result. But the result of the part 2, there are difference between voltage. There are different between voltage, but current is the same. During part 3, there are current that was difference of the result, but the voltage is the same of each other. We discuss about the result. We managed to come up a little bit of data regarding the series and parallel connection. For the series connection, there are 3 things, which is the voltage of the series connection are the sum of voltage between the resistor of the circuit, but the current of the series connection are the same. Also, the resistance in the series connection is the sum of the resistance of the resistor. Also, we can also search for resistor using the formula V equal to IR. And next, for the parallel connection, the voltage of the parallel connection is the same for all the paths, but the current in the parallel connection is the sum of the current we measure by the ammeter of the different path. And the resistance, we need to use the formula that was given, so that we can measure the resistance in the parallel connection. Also, we can use V equal to IR formula. Conclusion of the experiment: current and voltage in series and parallel connection give a different reading of each other. The result was measured by the ammeter and voltmeter, and then the resistor in the circuit can be measured by the formula V equal to IR, or also by using the resistance in the circuit.
Hi and Assalamualaikum. My name is Nabiha binti Muhammad Nizam, the last presenter for this presentation, and I'm going to be presenting the fourth experiment, which is magnetism. So as usual, before we start our experiment, we must find our objectives. So the objective of this experiment is to study the magnetic field and to determine the relation between the amount of field strength and current. Since we're doing this experiment through simulation, the first step is to click and open the link given, and the first picture will appear. Second, move the compass around the bar magnet to see which pole of the magnet does the red compass needle point towards. Next, flip the polarity and find the same thing. So in the second picture, there is a blue box which is the field meter. Move the field meter around the magnet to see if the fields increase or decrease as the meter is closer to the magnet. Move the meter about 1 inch away from the north pole of the magnet and record the magnitude of field strength. Do the same thing on the south pole of the magnet and see if its magnetic field are the same. Moving on to the electromagnet, which is the third picture. Move the compass around the electromagnet to see which pole is the left side of the electromagnet. Repeat step 4 to 6 with the left sides of the electromagnet. Adjust the number of loops in the electromagnet and record the field strength. Set the number of loops for the electromagnet back to 4 and adjust the voltage in the electromagnet and record the field strength. So the first table is showing the effect of different number of loops towards the field strength produced. The result shows that the higher of the number of loops, the higher the field strength. While the second table is showing the effect of different voltage towards the field strength produced. The result shows that the higher the number of voltage, the higher the field strength. In every experiment, there is always an error, although we tried so hard to prevent it. The error that can be found during the experiment is the compass that was used is not in a good condition. This will result in the mistaken of the pole of the electric field. The second error is the connection between the circuit is not properly connected. If this occurred, the results of the field strength produced by the electromagnet will not be accurate. By looking at the error, we must take some precautions every time we do an experiment. Firstly, we must make sure that the compass that is used is in a good condition. The compass must be properly placed at the right position. Always check the connection between the circuit of the electromagnet used. And lastly, the difference between the voltage has to be properly differentiated. All of these precautions must be taken seriously in order for us to have an accurate result. By doing this experiment, we can conclude that the definition of magnetic field is a vector field of a magnet, electric current, or changing electric field, which magnetic forces are observable. Magnetic fields cause the electricity charged particles to travel along a circle or helical direction. We can also determine the relationship between the amount of field strength and current, which is the strength of a magnetic field is directly proportional to the current flowing. Therefore, if an alternating current is flowing, a magnetic field around the conductor will be produced. And that is all from us. Thank you very much and have a nice day.